Welcome to the first video of the S. Hagen Repairs YouTube channel. In this video we'll be talking about a Thyratron DC motor drive that I built from scratch using a mixture of old and new. The tubes are type 5559, also known as FG57 by General Electric. And for the grid control circuit, I built up a little circuit board using op amps and comparators to do zero crossing detection off the AC line, convert that to a square wave and then to a ramp, and then comparing a DC control voltage to the ramp waveform to determine the firing angle. I've just got a oddball DC machine as a load right now, with the triplet meter as a output current meter, and this little Hewlett-Packard power supply as the control voltage source. I found that the drive was a lot more stable if I had somewhat of a resistive load in parallel with the brush DC motor. This seems to suppress the brush arcing noise that was otherwise causing the tubes to kind of go haywire. So we will power it up. The filaments are already warmed up. There's at least 5-minute time delay relay to prevent the plates from turning on until after the heaters have had sufficient time for the mercury vapor to warm up. We'll turn on the plate switch. That also turns on the field winding, and I have a light bulb indicating that the field voltage is live, and we will give it some control voltage. Start slow. So you can see this is able to control down to a very minimal speed on the motor. We'll raise it up a bit. It's fun to watch the mercury vapor glow change with the current flowing through the tubes. Probably in a later video we'll get into the actual underside of the circuitry, but this is just a DC bias adjustment for the grids of the tubes. Applies a negative DC bias because almost all mercury vapor Thyratrons are negative control, so they have to have a negative voltage applied to the grid to keep them off, and then you apply a positive voltage to turn them on. In the case of this circuit, I'm applying about a 5 or 10 microsecond positive pulse to the grid using a comparator circuit. So this also features current limiting. So if I lock the rotor and turn up the current, it'll kick out at about 4 amps, 5 amps, which is around the limit of the 2 tubes in push-pull like this. We can sort of demonstrate that by just ramping up the speed too quickly, and it'll kick out. So there it kicked out. And then after a short delay, actually I gotta turn the speed control down. It kind of tries. It might build up speed and get to the point where it gets below the current threshold, but we'll turn it down a little bit further. It takes right off and goes. So that just protects the tubes from exceeding their current rating, which is 2.5 amps per tube. And when you're only operating them half the time, which is the case when you're doing a full wave rectification, you can actually end up getting about 5 amps output safely. The tubes, I believe, have a peak current rating of about 15 amps, so those peak events don't really hurt them, but you just don't want the average current to exceed 2.5 amps per tube. So, hope this was interesting, and we'll dive into the technical details later, but feel free to ask any questions that you have, and I hope to make a lot more videos soon. This is a fairly new channel, and I'm going to try and do some interesting projects on here. Thanks.